So now that you have an inkling of how Project Reactor works, I'm going to talk about the case study we'll be applying, or case studies, because we have a bunch of them, to demonstrate how these things work in practice. And this is going to involve the use of our good friend BigFraction again. So if you recall, BigFraction is a class that supports arbitrary precision fractions, that uses these big integers for the numerator and denominator. It has factor methods to reduce fractions, so 44 55ths turn into 4/5, 12 24ths turn into 1/2, and so on and so forth. That should be familiar by now. It also has factor methods to create non-reduced fractions and then reduce them later. And the reason we would do that later is so we can do the reduction in another thread of control, which might benefit from concurrency and multi-core processing. It also supports, of course, arbitrary precision fraction arithmetic, or BigFraction arithmetic, where 18/4 times 2/3 equals 3. You just have to trust me on that one. And then you can also have methods to create a mixed fraction from a so-called improper fraction. So you can take an improper fraction like 18/4 and turn it into 4½ So we've got a lot of case studies. I'm not going to go through them all in detail right now. I'm just going to tell you that they exist, and then we will go through detail as we talk about the different operators in Project Reactor. And these case studies do a lot of different things, but basically, if you boil it down to a nutshell, they will use various factory methods from monos or fluxes to create big fractions. We will use various methods to reduce the big fractions. We will multiply them. We will display them. We will do this synchronously. We will do this asynchronously. We will do this with various concurrency models using Project Reactor. In our case, there's also an equivalent set of RxJava examples. So if you're ever curious, since we're not really covering RxJava in this class, if you're ever curious, you can go back and see how the RxJava stuff would work as well. And we're going to show a bunch of things with monos, and we're going to show all these cool operators like zip and zip with and when and first and all this good stuff. So there's all kinds of fun things there. And we're also, of course, going to show how to use flux operators like flat map and map and collect list and subscribe and all this good stuff. So you'll get a real good, deep understanding of many, perhaps not all, but many of the key operators that are defined in Project Reactor. And we're also going to see some cool ways in which you can take Project Reactor and its streams framework and transparently integrate it in with classic Java streams. So if for some reason you're in a situation where you have to combine different streams paradigms, they work together quite nicely. And in fact, as you will see, Project Reactor, because it's based on Java 8, supports all the stream operators as well. So in stream functional interfaces like function and supplier and consumer and collector and all this good stuff. So you'll have a lot of familiarity from what we've covered before. Then there's also equivalent RxJava examples, which we will not talk about because we're not going to have time to do that. But as I mentioned before, every Project Reactor case study has an equivalent RxJava one, so it's kind of like a Rosetta Stone if you want to see how the other way of doing reactive streams, the other popular way of doing reactive streams with Java could be realized. Just take a look at those examples too.